Hello everyone, I'd like to welcome you to the video titled Exponents, and in this video we are going to learn how to write and evaluate numerical expressions involving whole number exponents. And what I would like for you to do is get out your math journal and a pencil, and you will need to follow along with me. Now, as we begin taking a look at exponents, we're going to take a look at some key vocabulary. All right, so the first one is power. All right, and I want you to write this down. It says a number that is formed by repeating multiplication of the same factor, which leads to our other two definitions. As far as what you need to write a power is you need an exponent and a base. Okay, so what we have here, we have a number that reads 7 to the power of 3. So we can see 7 to the power of 3. The base, I want you to write this down, the base is a number that is multiplied. So 7, since it's a number that's multiplied, is the base. So 7 to the power of 3. Now what this actually represents, this represents 7 times 7 times 7. This is just a much easier way and shorter way to write that. And now the exponent tells us how many times the base appears in the expression. So we have 7 to the power of 3. Where did I figure out how to write 7 times 7 times 7 is because the exponent, which is this small number up here, told me how many times the base appears in the expression. So I multiplied the base 3 times, 7 times 7 times 7. So those are the key vocabulary terms for this lesson. Now let's take a look at what this looks like. And we're just going to simply use exponents to write each expression. So we have 5 times 5 times 5, and what that will look like will be 5 to the power of 3. Okay, where am I getting the 3 from? Because I'm multiplying 5 by itself 3 times. We can see that 5 is the base, 3 is the exponent. 89, just the number 89, that's it. What we have here is 89 to the power of 1. Okay, so anytime you just have the number, the exponent 1, what that would equal would be just 89. So now taking a look at the next one, 7/12 times 7/12. This is a little different. Whenever you're writing fractions, you have to use parentheses when you're writing your exponent for the expression. And we have 7/12 to the power of 2. What that means, we are multiplying 7/12 by itself 2 times. And then we have 9 times 9 times 9 times 9 times 9 times 9. We can see that there are 1, 2, 3, 4, 5, 6 times we're multiplying 9 by itself. So 9 is the base, and then 6 would be the exponent, showing how many times you multiplied 9 by itself. Now let's take a look at when we have 0 as an exponent. Okay, so it can also be understood that whenever you are multiplying a number by itself multiple times and you're using exponents to write an expression, that, for example, 5 to the power of 2 actually represents 1 times 5 times 5. Okay, that would be another way to write that. So anything that has 0 as an exponent is actually just going to equal 1. So 5 to the power of 0 equals 1, because what that would mean, when we're taking a look at this, we have 5, so not 5 to the power 2, but 5 to the power of 0. What that would represent would be 1, and we don't have any exponents that we're using at all. There's not any 5 times 5 or anything like that. So anything to the power of 0 will equal 1. 313 to the power of 0, that's going to equal 1. So understand that any number that has an exponent, any non-zero number that has an exponent as a power of 0 is going to equal 1. And then, on the other hand, I kind of showed you this with the other one. Any base that has an exponent of 1 is just going to be that base. So remember, when we think about how we're writing out these exponents, it's 1 times a certain number. It's going to be times 87. Okay, so anything that has an exponent of 1 is going to be that number, 87. 213 to the power of 1 is going to equal 213. Okay, so those are just a little confusing, so hopefully they are cleared up for you now. And let's keep moving on. So now let's take a look at what these would equal. Okay, so 6 to the power of 3, again, you can write it as 1 times 6 times 6 times 6, okay? Or you could just write it out as 6 times 6 times 6. Okay, so 6 to the power of 3, or you could even say this is 6 cubed, okay? 6 times 6 is 36, times 6 is 216. All right, moving down. 1 to the power of 7 is going to equal 1. All we're doing is multiplying 1 by itself 7 times, so that's just going to equal 1. 2 to the power of 3, what we have here is 2/3 of the power of 3 times 2/3 times 2/3. So we have 2 times 2 times 2, that's going to equal 8. And then 3 times 3 times 3 is going to equal 27. All right, now let's take a look at this next one. What we have is 2.5 times 5. So again, what we're doing here is we are multiplying 2.5 by itself 5 times. Okay, now remember that whenever we are multiplying, we have a decimal there. Okay, so it's important to understand that since we are multiplying this number by itself 5 times, that we are going to have a number that has 5 digits to the right of the decimal. And this number is going to equal, kind of big, you won't really have any like this, but just showing you here. So it's 97 and 65,625 hundred thousandths. Okay, so whenever you're multiplying by a decimal, please make sure you understand that however many digits are to the right of the decimal in your problem, that's how many digits are to the right of the decimal for your answer. And we talked about that in the last chapter. Now what we have here are negative numbers. Okay, so a negative base number, it's an exponent here. So we have negative 9 to the power of 3. Now understand that a negative times a negative is going to equal a positive number. Okay, a negative times a positive is going to equal a negative number. I know that may seem a little tricky here, but so what we have here is we have negative 9 times negative 9. That's going to equal positive 81. However, we're multiplying it by negative 9 again, and that's going to equal negative 729. I'll show you a little trick on how to figure this one out. Negative 3 to the power of 4 is actually going to equal positive 81. So here's a trick. Whenever you're dealing with negative numbers, negative base numbers, okay, if you have a odd exponent, your answer is going to be a negative number. If you have an even exponent, your answer is going to be a positive number. That's only whenever you have a negative number for your base. Okay, so just remember, a negative times a negative is going to equal a positive. Negative times a positive is going to equal a negative number. Okay, so negative 3 to the power of 4, we have negative 3 times negative 3, that's going to equal negative 9. Negative 9 times 3, I'm sorry, it's going to equal positive 9. 9 times negative 3 equals negative 27. And then negative 27 times negative 3 equals positive 81. I apologize for mixing that up here. So, but just the key tip, negative number, if it's multiplied by an odd number, is going to equal a negative number. Negative number multiplied, I should say, by an odd exponent. Negative number multiplied by an even exponent is going to equal a positive number. Now moving along to powers of 10. Okay, so really easy way to figure this out. However many, whatever your exponent is, I should say, that's how many zeros you will have in your power of 10. So I have my power of 10. I always write my 1 there. I have 3 as my exponent, so 3 zeros. Okay, so again, this represents 10 times 10 times 10. That equals 1,000. Again, simple way to know this. 3 zeros. My exponent is 3. Okay, so pretty easy to understand this. 10 to the power of 5, I write my 1. Whoops, I write my 1 down, followed by 5 zeros. 1, 2, 3, 4, 5. Pretty simple there for 100,000. So if I had 10 to the power of 87, I would write a 1, followed by 87 zeros. Okay, so that's something to understand whenever you're dealing with powers of 10 with exponents. Now let's take a look at this in a real world setting. I did get these questions from the Go Math book, and you can even see these on page 241 of your Go Math book. What we have here, it says Tim is reading a book. On Monday, he reads 3 pages. On each day after that, he reads 3 times the number of pages that he reads on the previous day. How many pages does he read on Thursday? So what we can see here is that, and you need to understand with these story problems, you always need to figure out what's happening first. So on Monday, he reads 3 pages, okay? And then on each day after that, he reads 3 times the number of pages he read on the previous day. How many pages does he read on Thursday? You can easily think, okay, you got to look at Tuesday, Wednesday, and Thursday, and that's it. However, do not forget Monday. Okay, so what this would be represented as would be 3 to the power of 4. Okay, so 3 to the power of 4, and what that would represent would be 3 times 3 times 3 times 3, and that's going to equal a total of 81 pages. That he reads on Thursday. Okay, so 3 to the power 4 and 81 actually represent the same number, but 81 is just how we would, you would not say to somebody that you read 3 to the power 4 pages on Thursday. You would say you would read 81 pages. Okay. Next one, Antonia is saving for a video game. On the first day, she saves $2. Each day after that, she doubles the number of dollars she saved on the previous day. How many dollars does she save on the 6th day? So what we have here of the first day, also basically going all the way to the 6th day, we know she's saving $2 a day, so that's going to be our base. What's going to be our exponent? 6 is going to be our exponent. Why is that? It's because we're trying to figure out how much she saves on the 6th day. And 2 to the power of 6 dollars could work, or if you're writing this out, think about 2 times 2 times 2 times 2 times 2, and then another times 2, I believe. So 1, 2, 3, 4, 5, 6 total. Multiply all this together, and that's going to give you $64. Okay, so that concludes our video on exponents. If you have any questions about this concept, please come and see me.